Hello everyone, welcome to Akademi Ekonometri. In economics course, we will continue with week 4. These are the topics we are going to cover in week 4, but in this part, in the first part of week 4, we will try to understand what does elasticity mean, and I will define the price elasticity of demand with some formula. And in the second part, we will cover income elasticity, cross price elasticity, and finally, price elasticity of supply. At the end of the second part, we will try to do a case study, and in this one, I will try to explain how elasticity is important for economists. Let's start with the elasticity, the definition of elasticity. Elasticity is the responsiveness of buyers and sellers to changes in market conditions. This is a really broad definition, elasticity definition. So when we define price elasticity of demand, we will try to understand the responsiveness of buyers. But on the other hand, if we try to define the price elasticity of supply, we will try to understand the responsiveness of sellers. So this definition is really general, but it applies to any kind of elasticity. And right now I'm using an example like rubber band. Rubber band is elastic, and if you apply some force to the rubber band, it stretches. So basically, changes in market condition is kind of a metaphor for the force we apply to a rubber band. We apply some force, that means there is a change in the market conditions, and the responsiveness of buyers or sellers is coming from how much we can stretch this rubber band. If you can stretch the rubber band with a little bit force, that means this rubber band is really elastic. On the other hand, if you apply the same amount of force, that means same amount of market change, but this rubber band this time is not stretching much. So that means the responsiveness is low. So as a result, I will say that a rubber band is elastic if I apply a small force, but the rubber band stretches a lot. Elasticity has the same meaning. If there's a little bit market condition and the response is high, we will say this demand or supply is really elastic. I don't want to make you confused a lot right now, but first of all, we will try to understand what is price elasticity of demand, and hopefully while we are covering that part, you will understand the elasticity more. First of all, we will start with price elasticity of demand, but we have to recall the law of demand. Law of demand is actually telling us there's an indirect relationship or inverse relationship between the price and the quantity demanded. And that's why our demand curve is downward sloping. Price elasticity of demand is going to cover that inverse relationship. But in this case, instead of the direction of the relationship, in the price elasticity of demand, we care about the sensitivity of the relationship between the price and the quantity demanded. So basically, elasticity or price elasticity of demand in this case is a measure of responsiveness of quantity demanded to a change in price. Let's take the rubber band again. We change the price a little bit, which is a force we apply to rubber band. And at the end of this change, we stretch the rubber band a little bit. If the responsiveness is high, we will say this demand is elastic. If the responsiveness is really low compared to the force that we apply, we will say this demand is inelastic. So we will do a lot of examples about elastic demand or inelastic demand. But first of all, let's try to understand why we need elasticity. So to explain you this part, I will ask one question. And imagine in this question, you are the firm owner and you want to increase your revenues. Should you raise the price or lower the price to increase the revenue? That's the main question you care about. And let's try to find out how we calculate the revenue. The total revenue is actually calculated by the multiplication of price and the quantity. And because of the law of demand, I know that when price increases, the quantity demanded will go down. So there is an inverse relationship. But the ultimate question is, do I know what's going to happen to total revenue when I increase the price or decrease the price? Let me elaborate that a little bit more. I will define the total revenue as TR, and it is the multiplication of price and quantity. And because of the law of demand, I know that the relationship between price and the quantity is inverse. So for example, when price decreases, the quantity demanded should increase. So let's see if we can find out what's going to happen to total revenue when you increase the price or decrease the price. So let's say I increase the price that much, and the length of the arrow is showing me the magnitude of the change in the price. Let's say I increase the price that much, but the question is, I know for sure the quantity is decreasing, but the question is it going to decrease that much, the same amount as price, or higher than the change in the price, or lower than the change in the price? Because I know that when the quantity decreases at the same rate, at the same percentage, I know that in this case, the total revenue will just be the same. What I mean is, for example, I increase the price by 1% and the quantity decreases by 1%. So basically, total revenue is just the same. But what if the quantity decreases by 2%? In this case, total revenue is decreasing. But what if the quantity is increasing 0.5%? In this case, total revenue is increasing. So the law of demand is telling me that the relationship or the direction of the relationship between these two variables, but it doesn't tell me anything about the percentage changes. When there's a percentage change in price, it doesn't tell me anything what's going to happen to quantity in magnitude. Is it going to change 1%? Is it going to decrease by 2% or 0.5%? So we don't have that information. But hopefully, with the elasticity, I can tell exactly how much the quantity is going to decrease compared to the change in price. So, for example, if I have an elastic demand, that will tell me if you increase the price by 1%, imagine that you apply a force by 1%, but the response coming from the quantity demanded will be a lot more because the demand is elastic. And that's why the total revenue, and that's why the quantity will decrease more than 1%. And we will say the total revenue is going to decrease. We are going to cover this explanation again. What is elastic demand? What is inelastic demand? But that's the main idea, why we want to understand the elasticity. So if we know the elasticity, if we know the demand is elastic or inelastic, we can tell what's going to happen to total revenue at the end of a change in the market condition, which is coming, of course, from the price. Now let's see the formula for price elasticity of demand. Here we use E to refer elasticity, we use D to refer demand, and in the numerator we have the percentage change in quantity demanded. In the denominator we have percentage change in the price. And delta refers to change in this formula. Let's do one example. And in this example, we care about university parking pass, and the price in this market increases by 50%. And the response coming from the quantity demanded is 25%. Since the price is increasing, the quantity demand will decrease. We know that from law of demand. And if we plug these numbers in the formula, what we get is negative 0.5. This negative 0.5 actually showing the elasticity of the demand. It tells us if the demand is elastic or inelastic. So what is inelastic and what is elastic mean? Quantity demanded changes significantly as the result of the price change if the demand is elastic. So basically, we apply a change in the price, let's say it's 1%, but the change in the quantity demanded is higher in magnitude than the change in the price, we tell this demand is elastic. I changed the price by 1%, but the demand is changing more than 1%. In this case, demand is elastic. And when we say elastic, we actually mean the sensitive case or the responsive demand. Again, I'm using the rubber band metaphor because when you take the rubber band and if you apply a little bit force, let's say 1% force, but if the rubber band stretches more than the force you apply, that means it is elastic, it is sensitive or responsive. The opposite case of the elastic demand is inelastic demand. In this case, we apply a price change, but the response coming from the quantity demanded is smaller than the change in price, in magnitudes, of course. For example, I apply a 1% change in the price. However, the change in the quantity demanded is less than 1%. For example, 0.5%. Again, let's use the rubber band metaphor. We use a 1% force to stretch this rubber band, but unfortunately, it's not responsive enough. So that's why we can stretch the rubber band only 0.5%. So in this case, when we say inelastic demand, you need to understand it's unresponsive to the price changes or insensitive to price changes. So basically, elasticity means that if the demand, in demand case, if the demand is responsive to price, we will tell demand is elastic. If the demand is unresponsive to price changes, we'll tell the demand is inelastic. So let's turn back to our previous example. We found that the price elasticity of demand is negative 0.5. What does this numerical number or result mean? In this case, we know that since this value is less than 1 in absolute value, we can tell that when we change the price by 1%, the change in the quantity demanded is less than 1%, which is in this case 0.5%. So basically we apply some force, which is 1%, but the response coming from the quantity demanded is less than the force that we applied. So basically quantity demanded respond this price change relatively small compared to the price change. That's why we call this is inelastic demand. I'm going to show you the boundaries of elastic and inelastic demand in a moment. But for now, let's cover why this value is negative. This value should be negative because we know that law of demand tells us there is an inverse relationship between price and quantity demanded. When price increases, the quantity demanded will decrease. That's always true, and the reverse of it is true. So that's why elasticity should be always negative, except at one extreme case. I will tell you the one extreme case in a moment as well. But for now, let's try to cover the midpoint formula. So in the previous slide, I showed you a percentage formula, but sometimes this percentage formula is not enough to calculate the elasticity properly. For example, when price decreases from $100 to $80, the change in the price is 20%. However, when I increase the price from 80 to 100, in this case, the change in price is 25%. So basically, if you are moving from point A to point B, the change is 20%. But if you just change the direction, the change in price is 25%. So as you can see, if you use the percentage formula in this case, the direction will be important in calculation of elasticity. That's why to get rid of this miscalculation or the change in numerical values in the percentage formula of elasticity, we have to use midpoint formula. And one important point is we have to use midpoint formula or method when the change in price or the quantity demanded is really large. For example, when we move from 100 to 99 and 99 to 100, the percentage change in both cases will be almost similar. But when we increase the gap between the changes, when we move from 100 to 80 and 80 to 100, and in this case, the percentage change will be different for both directions. So the main idea is, if the gap between these changes is small, yes, you can use the percentage change formula. However, if the gap is huge or large, as in this case, when we move from 100 to 80 or 80 to 100, the percentage change formula is not going to work. So that's why we have to use midpoint formula. So what's the midpoint formula? Here, this is the formula for midpoint method. And to help you understand this formula better, I want to do some mathematical manipulation in our main percentage formula. So this is what I'm going to do. I will just try to write the percentage formula as you saw before, and I will do some mathematical changes. As you can see, I can write the numerator like this: change in quantity demanded divided by quantity demanded, which is multiplied by 100, because here we have percentage. And I can do the same thing for the denominator: change in price divided by price and multiplied by 100. And let me do some simplification. So the formula becomes to this: of course, quantity demanded and per change in price divided by price. So basically, this is our elasticity formula if we get rid of the percentage changes here. And let's turn back to midpoint formula. In the midpoint formula, as you can see here, instead of dividing by the initial quantity to get rid of the direction, discrepancies between direction, we use the average of quantity demanded. So here, instead of using Q1 only, we are using the averages of the initial and the final quantity demanded to get rid of the discrepancies between directions in the calculation. So now let's see the midpoint method in parts. Here in green area we have the change in quantity demanded, and then in the blue area we have the average of quantity demanded. In the yellow one we have the change in price, which is actually really similar to our percentage formula, and then we have the average price in the red area. Now let's do some example and try to understand this midpoint method better. In this example, the initial price is $6 and the final price is $4. As a response to that price change, we have the quantity demanded increasing from 15 to 25. The only thing we have to do is plug these numbers into midpoint formula, and as a result we have a price elasticity of demand which is equals to negative 1.25. First of all, the negative sign is coming from the law of demand, because price is decreasing here, so the quantity will increase. That's why we have the negative sign. For a moment, let's forget the negative sign. This 1.25 is telling me that if I increase the price or decrease the price by 1%, the change in the quantity demanded is 1.25%, increasing or decreasing depending on the situation. So basically, the force we apply is 1%, but the response coming from the quantity demanded is higher than 1%. That's why we will tell this kind of demand as elastic demand. Now I want to show you all of the possible cases that
elasticity can take in the demand case. And I'm going to use my scratch paper. In the scratch paper, first of all, I will write a line, and this line is going to start from 0 and it will continue until negative infinity. And negative infinity and 0 are my extreme cases. Let's first try to define these extreme cases. So if the price elasticity of demand is 0, that means it is perfectly inelastic. I want you to remember the price elasticity of demand formula as well. As you can see, if this value is 0, the change in the quantity demanded, the value in the numerator should be 0 as well. So basically, I'm decreasing the price a little bit by increasing or decreasing the price, but the response coming from the quantity demanded is basically 0. So the quantity demanded is not changing. That's why it's not elastic. That's why it is perfectly inelastic in this case. Elasticity is 0. So the other extreme case, we have the price elasticity of demand is negative infinity. Again, if we use the same formula, this time we will have negative infinity instead of 0. If negative infinity is the elasticity, that means if I change the price even a little bit, let's say 1.001%, the change in quantity demanded in percentages should be really large. So we have an infinite value. So basically, I changed the price a little bit. The force I did is really small compared to change in the quantity demanded. That's why in this case, the elasticity is huge or extreme. That's why we call this case perfectly elastic case. And here we have one important value as well, -1. If the price elasticity of demand is -1, that means when I change the price by 1%, the change in quantity demanded is again 1%. Of course, there is the inverse relationship. That's why we have negative in front of 1. So basically, we will call this value as unit elastic. Here, as you can see, we have some other values here between -1 and 0. If this is the case, we will call this part of demand is elastic. Inelastic. In the inelastic case, we apply, for example, a 1% change in the price, but the response coming from the quantity demanded is less than 1%. Again, we can use the formula to have this value between -1 and 0. The upper value needs to be smaller in magnitude than the value in the denominator. The other possible values are the price elasticity of demand between -infinity and -1. This case we have elastic case. In the elastic case, the situation will be like this. We increase the price by 1%, but the response coming from the quantity demanded will be higher than 1%. For example, 2%. And again, if you use the formula, this is what we will get. We increase the price by 1%, and let's say the response coming from the quantity demanded is 2%. Of course, there is an inverse relationship. That's why we have a negative sign in the front of the value we are going to find. That's why, let's say, we find -2. So -2 will be between -infinity and -1. So this is the case we will have in the elastic demand. Now let's turn back to our slides. Here in this slide, I show you inelastic case on the left hand side and the elastic case on the right hand side. In the scratch paper, the elastic case was on the left hand side, inelastic case was on the right hand side. So in this slide, 0 is here. We increase the elasticity and -infinity is here. So you know that in the inelastic case, the responsiveness compared to the price change is low. In the elastic case, the responsiveness coming from the quantity demanded compared to a change in price is high. So these are the examples that I'm going to give you. Here, first of all, you will see that the demand for Honda cars is elastic. We are going to see why this is the case. Fresh vegetables is also elastic, which means that when you increase the price of fresh vegetables, the response coming from the quantity demanded will be pretty high. We have airline travel elastic, restaurant meals elastic, so people are sensitive to these kind of goods and services. When there is a price change, the response coming from the quantity demanded is huge compared to that price change. But on the left hand side, we have the inelastic cases, which means the response coming from the quantity demanded is low compared to change in price. The first thing we noticed here is the tobacco products. In the tobacco products case, we know because of the addiction, nicotine addiction, these people or smokers, they don't care about the price a lot. They only care about how many cigarettes they are smoking every day. So basically, when there is a price change, let's say 10%, the response coming from the quantity demanded is lower than 10%. And medical care is also another example for inelastic case because health is much more important than anything you can imagine. And if the price for doctor visits are really high, you still have to go to doctor, you will go to doctor. So your response coming from the quantity demanded will be low compared to that price change. And one more thing is, here we see one more airline travel here. So basically, we have one airline travel which is elastic and the other airline travel which is inelastic. The difference is coming from the consumer preferences. And I'm going to tell you that in this case, in the inelastic case, imagine that you're a businesswoman or businessman and you have to go to Istanbul next day. You have an important meeting. So basically, you don't care about the price. You only care about the service you got. You want to be on that plane. So if the airline travel increases the price by 50%, still you don't care. You have to be there, so you have to consume that good. Therefore, when there's a price change like 50%, the response coming from the quantity demanded for these business people will be lower than 50%. So maybe the quantity demanded will decrease only 5%. So in the inelastic case, price is not really important. The most important thing is getting or consuming that good or service. The item is more important. But in the elastic part, price is a lot more important than the quantity. As long as the price is low, yeah, people want to consume that good. When the price increases a lot, the response coming from the quantity demanded is a lot. In this airline case, I want you to imagine yourself as a student or a traveler who travels when his or her leisure time. So you care about the price. You have enough or plenty of time. You can go to another country this week, maybe next week, maybe other week, as long as the price is right. And in your case, let's say you want to go to Paris in next week and suddenly the airline prices increased a lot. So your response will be directly not going to Paris next week because you know that if you go Paris in maybe 2 or 3 weeks from now, you will pay less money. So your response coming from the quantity demanded is really hard, really big compared to the change in price. That's why I'm going to tell you that the elastic and inelastic demand cases are also sensitive to consumer preferences. In this case, consumers are much more caring about prices, but in the other case, in this case, consumers are caring about the quantity or the service in the inelastic case, but in the elastic case, consumers care about price. So, in the next slide, I want you to show you all of the possible elasticities, demand elasticities, with the extreme cases. Let's start with the perfectly inelastic one. In the perfectly inelastic case, as you know before, the coefficient is 0, and the interpretation is price doesn't matter. Price is not important, because even if you increase the price by 200%, 1000%, still you are not going to change the quantity demanded. And the easiest example that you can remember is your pet. So if I want to buy your pet for a lot of money, most probably most of you are not going to sell their pets. So price is not important. The only one is the quantity, having that item, purchasing that service, whatever. And in the other extreme case, I'm telling you, in the other extreme case, it's the perfect elastic, and the coefficient is negative infinity. And in this case, price is everything, because negative infinity is telling me that if the price increased by 1%, no one is buying that good. The change in the quantity demanded is so high. That's why the numerator value is so high, and the change in price is so low compared to the numerator value, the change in quantity demanded. So using the formula, we will get a negative infinity. Here the example is a $10 bill. $10 bill I'm saying because price has a value, the paper bill has a face value. It says $10 bill. If you give that $10 bill to the Federal Reserve Bank, and they have to give you back a real good which has a market value of $10. But suddenly, let's say if the Federal Reserve Bank tells you that if you give me that $10 bill, I will give you only $5 a real value which has a $5 market price. So basically, you give them a $10 and they give you back a $5 real value. So since the price is everything for the money, you don't want to use that money, $10 bill, because basically you are getting less than what you got in your hand. And the relatively inelastic case, the coefficient is between 0 and -1. In this case, price is less important than the quantity. You want to purchase that goods. Yeah, you care about the price, but a lot less than the quantity purchased. The easiest example is electricity. In 21st century, as you know, electricity is really important. So if, let's say, the cost for electricity is increasing really a lot, you are still going to use it. If the price increased by 20%, you are not going to decrease the quantity by 30%. You can only decrease the quantity maybe 5%, maybe 10%. So your response coming from the quantity demanded will be a lot less. That's why we say electricity in this case is relatively inelastic. In the unit elastic case, the coefficient is -1, and price and quantity are equally important. So you increase price by 1%, the quantity demanded is decreasing by 1%, and vice versa. In the relatively elastic case, price is more important than the quantity that you purchase, because there are a lot of reasons to have an elastic demand, but in this case, let's say when we increase the price by 1%, the quantity demanded is going to decrease more than 1%, maybe 2, maybe 4. We call these kind of cases relatively elastic case. So the next topic is the determinants of the price elasticity of demand. And in this topic, you will understand how we can get elastic demand or inelastic demand. The first determinant is existence of substitutes. Goods with lots of substitutes will have a elastic demand, more elastic demand. And the idea is, let's think that we have two different brands of breakfast cereals, and price of brand A is increasing by 20%. If this brand A breakfast cereal has a good substitute, you can easily switch to brand B breakfast cereal because there's a price increase in brand A. So as you can see, to a price change, consumers can give a really huge response with the quantity demanded. If you increase the price by, let's say, 10%, the response coming from the quantity demanded will be more than 10% because this good has a substitute, a good substitute. Consumer can easily switch to other goods. But goods with no substitutes will become more inelastic. And the examples are like, for example, rare coins and Broadway theater, electricity, we covered that before, Super Bowl tickets, because these are one-time events and not really good substitutes. They are not really good substitutes for these kind of events. So even if the price increase for these goods, we know that the quantity demanded is not going to respond as much as the change in price. The second determinant is necessities versus luxuries. This kind of selection affects the options of the consumer faces. So the idea is we will divide the goods into necessities and the luxuries, and for the necessities, examples are bread, drugs, milk, cheese. So these are the goods that people want to buy all of the time. So even if the price increases a lot, they are not going to respond with the quantity demanded to a change in price because they have to get these items, these goods and services. That's why for the necessities, the demand will be inelastic. For example, let's imagine drugs. The price of the drug that you use increased by 50%. You cannot stop purchasing or taking these pills. You have to get these pills. Maybe you can decrease the amount. So when there's a 50% increase, you will decrease the amount by 20% only. So your response coming from the quantity demanded will be much less than the change in price. But for the luxuries, you can live without a diamond ring. You can live without these jewelries or something else. So basically, when the price increases a lot, your response coming from the quantity demanded will be much more. Let's say the value of the ring increased by 100%. Yeah, you will respond to that price change a lot harder than the price change in the drugs. That's why for the luxuries, the demand will be elastic, and for the necessities, demand will be inelastic. Third one is the share of the budget spent on the good. So the easiest way to understand this determinant is to answer this question. Which will you react to more? So in which case you will react or you will give a bigger response in quantity demanded? When there's a 20% sale on a new vehicle you want, or when you have a 20% sale on a candy bar. So in each case, as you can see, the price is decreasing, so the quantity demanded will increase, that's for sure. But in which case the response is higher? Imagine that the new vehicle value is $30,000. So a 20% discount is approximately $6,000. So in the candy case, the value of the candy bar is $1. When there is a 20% sale, you're only getting a 20-cent discount. So as you can see, in the first case, this $6,000 is really huge. So you will respond a lot more in the first case. For a new vehicle, you will respond a lot more. So basically, for the items that take the higher or larger portion of your income will have more elastic demand. But for the items that takes a little portion of your budget will be more inelastic. So low budget items will be inelastic, high budget items will be elastic. The third one is whether the market is broadly or narrowly defined. And this determinant also affects the options of the consumer faces. Now we will define the broadly defined market and the narrowly defined market. In this case, I want to use the example of milk. In the broadly defined market, I'm going to say I'm only talking about the milk market. I'm not talking about a skim milk or 1% milk, 2% milk, low-fat milk, these kind of different types of milk. I'm just talking about the broadly defined market, like milk market only, that's it. But in the narrowly defined market, I want to talk about only about skim milk. And let's start with the narrowly defined market. In that narrowly defined market, we are talking about the skim milk. If the price of skim milk increases by 50%, as a rational consumer, you might want to find out some good substitutes of skim milk. Maybe you will switch to 1% fat milk. So basically, the response you will give in this narrowly defined market when there's a price change is huge, because 50% increase in milk is really huge difference. So the quantity response change, the response coming from the quantity demanded will be high too. But when we are talking about the broadly defined market, we are trying to understand what happens to quantity demanded when there is a change in the whole milk market, milk industry. So the price of all milks are going up. So I'm not talking about specifically skim milk, but all of the milk types are going up by 50%. And in this case, if you really want to drink milk, not kind of vegetable milks, almond milk, or some kind of other milks, your response coming from quantity demanded to a price change like 50% increase will be a lot less. You cannot respond because there is no good substitute for the broadly defined market. If you are not going to drink that milk, what are you going to drink? That's the only option you want to drink. That's why your response in the broadly defined market will be a lot less. That's why we will call, in these kind of markets, demand is inelastic. And the last one is time and adjustment process. Generally, demand for goods tends to become more elastic over time. Over time, consumers are more able to find substitutes. We are more able to adjust for price change in other ways. And the idea here is, I usually give example of iPhone. In 2007, we got the new iPhone. It was the first smartphone in the world. But the price at that time is really huge, and they were increasing the price however they wanted. And the response coming from the quantity demand was really low because there wasn't any good substitutes. But with time, we have some other brands, Chinese brands, American brands, or brands from other nations. So basically, in the smartphone industry, we have more substitutes. If there are more substitutes, the demand tend to be more elastic with time. So more substitutes, more elastic. And also, during that time, consumers are adjusting themselves to price changes like that. For example, in 2007, there wasn't any other kind of communication devices like tablets, iPads, this kind of stuff. But right now, we have much more communication, other kind of communication devices. So basically, we are adjusting ourselves, and the prices we are more responsive to price changes than before. And in this slide, we want to use the determinants of elasticity, and we want to analyze what happens to the turbo band demand and booster demands. Which one is more inelastic? And here, I want to show you that video clip a little bit, but unfortunately, due to YouTube copyright claims, I cannot play that video clip. But after you watch it, you will see that Turbo Man is a toy. It's really popular and everyone wants to buy it. Even if the price is really high, they don't care. They want to buy it. So the response coming from quantity demanded is really low. But on the other hand, Booster is just a helper for Turbo Man. So no one cares about it. So if the price is really goes up, they don't want to buy it anyway. So the response coming from the quantity demanded is really huge. In this case, the Turbo Man will have an inelastic demand and Booster will have an elastic demand. Now let's see the relationship between price elasticity of demand and the slope of the demand. And if the demand is relatively elastic, the demand curve will be relatively flatter. If the demand is relatively inelastic, the demand curve will be relatively steeper. So basically, inelasticity and the high slope will be related, and the elasticity and flat slope or low slope will be related. To help you understand this topic better to you, I'm going to use my scratch paper again, and I want to first of all draw a regular demand curve. On the x-axis we have quantity, on the y-axis we have price, and the slope of this demand is rise over run, which is the change in y-axis value and divided by the change in x-axis value. And I know that on the y-axis I have price, on the x-axis I have quantity, and I will refer that as m. So I'm going to use this as my slope in this demand curve, and at the same time I want to use the price elasticity of demand formula. I will first start with the percentage change formula, and then after some manipulations I get this. You can check the beginning of this video and you can understand how I come from percentage change formula to here. So I will do some more manipulation, as you can see. So as you can see, my slope is this, and on this demand line the slope is always constant because this demand line is a linear line. So basically this value, the division of change in price and the quantity, change in quantity, is always the same, and the change in quantity divided by change in price is actually the inverse of the slope. I see this term in the price elasticity of demand formula. This is 1 over m. So 1 over m multiplied by price divided by quantity, this is my price elasticity of demand. So as you can see, the price elasticity of demand and the slope is related. It's kind of inversely related, but not that's not the all. We have one more term, and it is price divided by the quantity. For now, let's forget about this term, price divided by quantity, and we can approximately say that the price elasticity of demand and the slope of this demand line is inversely related. Let me try to draw different cases of demand. So in this case, I will start with a flat demand line, which is again linear. And in this case, slope is 0. Since slope and price elasticity of demand, they are inversely related, since the slope is 0, which is the lowest extreme case I can have, that's why in the price elasticity of demand case, I will have the extreme case of elasticity. So in this case, the elasticity is maximum, so the coefficient will be minus infinity, which will tell me that perfectly elastic case. The elasticity of this demand line is at the highest. And then let's do the demand case mostly flat but not a horizontal line. So here you can say that slope has increased compared to this one, so it's larger than 0, but it's not 1, it's not maximum amount, but it's increasing. That's why the price elasticity will be between -1 and -infinity. So in this case, it's elastic. Because when we move from D1 to D2, as you can see, the slope is increasing. When slope is increasing, since the slope and the elasticity is inversely related, the elasticity is decreasing compared to the previous case. Now let's see the other case. So as you can see, it is steeper than D2. D3 is steeper than D2. Slope again is increasing. Again, elasticity will decrease. So we will have a unit elastic case in this case. It's unit elastic. And we will make the demand curve steeper here. Slope is increasing. So the price elasticity of demand will be between 0 and -1. This is inelastic case. Look, when we increase the slope, elasticity is decreasing. That means inelasticity is increasing. And in the fifth case, I have a vertical line, D5 vertical demand line. In this case, slope is 1 and elasticity is 0. And this is perfectly inelastic. I'm sorry, this slope is not 1. The slope is infinite. So as you can see, when the slope is increasing, the elasticity is decreasing, or the inelasticity is increasing. So in my opinion, the easiest way to remember whenever the demand is elastic or inelastic is, if you see a vertical demand line like this, this is inelastic because there's an I sign here. And when you see a flat demand line, you can draw two more lines and we have an E letter here. That's why it is elastic case. And whenever you increase the slope starting with the elastic case, you will have more inelastic and more inelastic case every time. We started with perfect elastic, we increase the slope, inelasticity is increasing, elasticity is decreasing, inelasticity increasing, inelasticity increasing, at the same time elasticity is decreasing. This is the first part you have to understand about the graph about the slope and the elasticity relationship. And also the other part is, on a given demand line, there are three portions that you need to know. The first one is, if we divide the demand line into two parts, the upper part will be the elastic case and the middle part will be unit elastic, and the bottom part will be inelastic case. And the idea is actually coming from the formula of price elasticity of demand. I'm going to use this formula. Remember, after some manipulation, we got this formula for the price elasticity of demand. And I know that this is the inverse of slope, so this is constant. And for now, I'm not going to think about that, because when I move from this point A to B, and let's say C here and E here. So when I move from point A to B, B to C, and C to E, I know the slope of this line will be always the same because it's a linear line. The only two things which are changing in this case is the price and the quantity. Here, let's imagine what's going to happen when we move from point A to B. So as you can know, as you can see, I'm not using the midpoint formula here. I'm trying to use the percentage formula here. That's why I have the initial price and the initial quantity. That's why at point E, I know that the value of price is much more than the value of quantity at point A. So that's why in the numerator I have a large value, in the denominator I have a small value on the upper part of the line, of the demand line. So this large divided by small gives me a large value, of course in absolute value. So most probably I will get, let's give some example to elaborate it. I will have maybe 9, negative 9, maybe negative 8. So these values are showing me that the demand is elastic. So in the upper case of the demand line, demand will be elastic. But on somewhere in the middle, the point C gives me, let's say PC and QC, P divided by Q. I will give a mid value of P and a medium value of quantity. When I divide, I will have negative 1. So that's why we refer it as unit elastic. But if we are at the bottom part of the quantity of the demand, what I will get is, again, P divided by quantity, and the other term is also the same. So P in this case will be small because, let's say we have a point here. At this point, P is much smaller than the quantity, and the quantity will be large. That's why I will have a value between 0 and 1, of course in absolute value. And if we add the negative sign, let's say we have 0.5, negative 0.5, which will give me inelastic case. So the first part you need to know about the slope and the price elasticity of demand is they are related, but they are not the same thing, because we have this second term here, but still we can say they are approximately negatively related. And in the second part you need to know is, on a given simple demand line, we have two different portions. In the upper portion we have inelastic case, in the mid portion we have unit elastic case, in the bottom portion we have inelastic case. Now in the slides I try to give you better graphics to let you understand better. Let's start with one extreme case, and this case is the perfectly elastic case. As you can see, we have a flat demand line. In that flat demand line, if we move from price P0 to P1, and on this price line, we are not hitting to demand line here. So basically, even if the price increases just a tiny bit, the quantity demanded is decreasing to 0. So that's the extreme change in the quantity demanded. That's why the change in the quantity demanded is extreme, a lot, maybe infinite, and the change in the price is really, really small. That's why we get negative infinity. In the other case, we have elastic demand. As you can see, it's not fully flat, fully horizontal, and the slope is small here. And if we increase the price from P0 to P1, as you can see, the change in quantity demanded, the response coming from the quantity demanded is large compared to change in price. That's why we divide big by small, and we get a big value in absolute value, of course. So in this case, we have the elastic demand. In this case, we are covering the inelastic case. Now, right now, the slope is high, elasticity is low, inelasticity is high. And if we increase the price from P0 to P1, the response coming from quantity demanded is low compared to change in price, as you can see. We divide small value with big value, and we get a value between 0 and 1. Of course, in absolute value, there should be a negative sign, but to explain that better, I'm usually dropping the negative sign here. In the perfectly inelastic case, we have a vertical demand line, and in this case, even if the price increase a lot, the change in quantity demanded is absolutely 0, because we have a vertical demand line. The price is not important here in this case. The most important one is the quantity demanded. That's why the change in quantity demanded in the numerator is 0, and we have a price elasticity of demand which is 0. No change in quantity demanded. In this slide, I want to show you how to remember the relationship between slope and elasticity. Elasticity of demand, actually. So relatively flat demand curves are relatively more elastic. We covered that part, and also we covered that relatively steep demand curves are relatively more inelastic. The easy way to remember this relationship is that steep demand curve looks like the letter I, so it is inelastic. And if you remember from our previous scratch paper, for a horizontal demand line, if we add an imaginary 2 horizontal lines, we will get the letter E, which refers elastic. So in this case, we are in the extreme one, so it's perfectly elastic. And for a vertical demand line, it's perfectly inelastic. So basically, when the slope increases, the inelasticity is increasing as well, and vice versa. In this slide, we are going to cover the relationship between time and the elasticity, and of course the slope of demand curve. So remember that when we were covering the determinants of price elasticity of demand, I told you that with time and adjustment, a demand curve will become more and more elastic. We are going to apply this knowledge here. So we will start with perfectly inelastic demand line. We have a vertical demand line here, and with time and adjustment, demand lines become more elastic, so it will be a little bit flatter than before. So we have a D2 demand line. And when we have more time and adjustment process, demand line will become more elastic, and our new demand line will be D3. So basically, when time and adjustment process increases, we have more and more and more elastic demand line. And of course, elasticity is related with the slope, so we have flatter demand line as well. So we covered most of these slides, the relationship between slope and elasticity. And the most important part you need to remember, keep in mind, is elasticity and the slope of the demand curve is related, but they are not the same. Slope is just the same at all points on a demand curve, but elasticity will be different at all points. You need to refer back to the formula that I manipulated a little bit more in the scratch paper. Elasticity decreases as we move down and right along a linear demand curve. Let me show you that information with a better graphic. Here on the upper region of the demand line, we have elastic part. On the mid region, we have unit elastic, and on the bottom region, we have inelastic part. And using the numbers given on that demand line, the numbers are given here, we can also calculate the elasticity by ourselves using the midpoint formula. If you calculate these numbers, these elasticities, you will confirm our results here. Upper part elastic, bottom part inelastic. So, okay. We now know that the demand elasticity changes along a linear demand function, but who cares? Why do we want to know this information? The first answer should be elasticity is related to total revenues. Firms care about profit, making more profit. So firms are interested in increasing total revenues. For now, we don't want to care, or we don't want to think about the cost portion. I'm going to show in a moment in a scratch paper. Firms will need to know whether to increase or decrease price to increase revenues. That's the main aim for us to use elasticity. If we know the elasticity, that value, firms can know when to increase the price to increase the revenue, or when to decrease the price to increase the revenue. That's the main idea here. So let's turn back to our scratch paper, and total profit is actually the difference between total revenue and the total cost. But for now, we will assume that total cost is 0. So basically, for a firm to maximize the total profit, that firm needs to maximize the total revenue. But in usual profit maximization, the firm is maximizing the difference of total revenue and total cost. Due to our small assumption, unharmful assumption, we are just assuming that total revenue should be maximized in this case. So we know that the total revenue formula is price multiplied by quantity. From law of demand, we know that when price increases, quantity demanded will decrease, or vice versa. But the question is, we don't know the change of we don't know the relative magnitudes of these changes. When we increase the price, how much the quantity is decreasing, or when we decrease the price, how much the quantity is increasing. We don't know. But if we know the elasticity, we can answer this question. That's why I will take three different cases. The first one is case elasticity. So we will assume that the firm is selling its products in the elastic portion, and in the second one, firm is selling its products in the unit elastic portion, and in the third case, the firm will sell its product in the inelastic portion. So in the elastic portion, we know that when the price increases that much and the length of the arrow is showing me the magnitude of the increase, the change in the quantity will decrease more than the length of that arrow. So let's say the length of this arrow is showing me a 1% increase, but the change in the quantity or the decrease in the quantity will be 2% decrease. As a result, total revenue is decreasing. So to make more profit or to make more revenue for the elastic case, the firm needs to decrease the price, because when the firm decreases the price by 1%, the quantity demanded will increase by 2%, so the total revenue will increase. So for the elastic case, you have to decrease the price. For the unit elastic case, when we increase the price by that much, the quantity is decreasing the same amount. So basically, total revenue is just the same. The same result will be achieved when we decrease the price. The quantity will increase the same, so the total revenue is the same. So basically, when you're on the unit elastic region, it doesn't matter if you increase the price or decrease the price, your total revenue will be approximately just the same. But however, if you are on the bottom portion of the demand, we will be on the inelastic region. If this is the case, the response coming from the quantity demanded will be lower than the change in the price. That's why the quantity demanded is going to decrease just a little bit compared to the change in price. As a result, total revenue is increasing. And if you decrease the price, the increase in quantity demanded will be a little bit. That's why total revenue will, in this case, decrease. So the result is, if you're in the inelastic portion of the demand line, you have to increase the price to increase the total revenue. If you are in the elastic portion of the demand line, you have to decrease the price to increase the total revenue. However, if you're on the unit elastic portion, it doesn't matter if you increase the price or decrease the price, your total revenue will just be the same. So using that knowledge, let's try to understand the same information on the graphic. On the left hand side, we have the elastic region. On the right hand side, we have the unit elastic region. And on the bottom, we have inelastic region. As you can see in the elastic region, the firm is decreasing the price and increasing the total revenue. The first total revenue, the initial total revenue is $4, the area of that rectangular. And in the final situation, the area of the rectangular is $6. So basically, the total revenue increased by $2. Here we have a $1 lost compared to the final situation because you increase the price of the good. However, you are gaining $3 more by selling one more extra unit for $3. So basically, the 3 square is the gain because you are selling more for less, and 1 square is the loss because you are selling the good for a low price. And in the unit elastic case, as you can see, the area of the first rectangle, the purple rectangle, is showing me the initial total revenue before the price change. It is $6. But after the price is decreased, the total revenue is again the $6 area of here. And we are losing 2 squares, $2, for selling that product $1 less. However, we are gaining $2 more for selling one more product here. In the inelastic region, we start at $2 and we decrease the price. Initially, the total revenue is the area of this rectangle, the purple one, and it is 6. And after decreasing the price of the good from 2 to 1, right now the firm is making $4 total revenue. So basically, if you decrease the price in the inelastic region, you are decreasing the total revenue. In this case, the firm is losing $3 because selling goods for $1 less and gaining only $1 for selling one more unit more. So end result is, if you're on the elastic region, you have to decrease the price to make more profit. If you're in the inelastic region, you have to increase the price to make more profit. However, if you are in the unit elastic region, it doesn't matter what you do, total revenue is going to be just the same. So we came to end of week 1, part 1. We will continue with income elasticity in the second part. Thank you for watching Akademi Ekonometri. Please don't forget to subscribe to the channel and like the video. I'll see you in the next video. Take care. Bye-bye.